In today's lesson, we will look at two more very simple rules for finding the derivatives of functions. Well, you already know how to find the derivatives of functions of the form, say, f of x equal to ax to the power of n. The power rule we talked about in one of the previous classes. What is the derivative of such a function? F prime x equal to, multiply the power with the constant a times n, x to the power. What happens to the power? That will be 1 unit less. So f prime x equal to an x to the power n minus 1. For example, if f of x equal to, say, x to the power of 7, what is f prime of x equal to? That will be 7x to the power of 6. How about this? F of t equal to 5t to the power of 8. Well, f prime of t will be 8 times 5, that will be 40, t to the power of 8 minus 1, that is 7. Well, this is how we use the simple rule for the power rule for derivatives. We will now look at another simple rule for finding the derivatives, that is the product rule for derivatives. What does that mean? Suppose you have a function f of x equal to, say, g of x multiplied by h of x. Well, each of this is a function of x. Then what is the derivative of f of x? What is f prime of x? The rule says, write down the first function, multiply it with the derivative of the second function. In other words, g of x multiplied by h prime of x. Now plus, repeat it now the other way. H of x times the derivative of g of x. Right? H of x times the derivative of g of x, g prime of x. It's a very simple rule. If f of x equal to gx multiplied by h of x, the derivative of f of x, that is f prime x, is g of x times h prime of x plus h of x times g prime of x. Let's use a simple example right away. Suppose our f of x equal to, say, x multiplied by sine x. You can see your g of x is x, your h of x is sine x. This is the product of two functions of x. How do you find the derivative of this function? F prime of x equal to the first function multiplied by the derivative of the second function. Now I'm going to write it like this. X multiplied by d by dx of the second function, d by dx of sine x, plus the second function, which is sine x, multiplied by derivative of the first function, d by dx of the second function is x. Alright, now tell me, that will be x multiplied by, what is the derivative of sine x with respect to x? Well, that's something that you should know. The derivative of sine x with respect to x is cosine of x. So that will be x times cos x plus sine x multiplied by, what is the derivative of x with respect to x? That'll be 1. The derivative of t with respect to t is 1. The derivative of p with respect to p is 1. The derivative of x with respect to x is 1. So what is our final result? That will be x cosine of x plus sine x. That is the derivative of x sine x. A very simple way of using the product rule. Alright, let's now look at another function. Say y equal to x squared plus 5 times 2x cubed minus 7. It's the product of two functions. We will call this as the first function and this as the second function. So how do you write the derivative? Well, the derivative of y with respect to x is dy by dx, or we can also write it as y prime. Is that right? Let me write dy by dx. So we have dy by dx equal to, how do you apply now the rule? The first function multiplied by the derivative of the second function. So that will be x squared plus 5 multiplied by d by dx of 2x cubed minus 7. Well, first function multiplied by the derivative of the second function plus the second function, which is 2x cubed minus 7 multiplied by derivative of the first function, d by dx of x squared plus 5. Okay, let's now simplify that. That will be x squared plus 5 times d by dx of the derivative of 2x cubed minus 7. Alright, what is the derivative of 2x cubed? Use the power rule. That will be 3 times 2, 6. That will be 6x to the power of 2, 6x squared. And what is the derivative of minus 7? The derivative of a constant is 0. So the derivative of 2x cubed minus 7 is 6x squared plus 2x cubed minus 7 multiplied by derivative of x squared plus 5. What is the derivative of x squared? The derivative of x squared is 2x. And the derivative of 5 is 0, so the derivative of x squared plus 5 is 2x. Alright, let's now simplify this. Just multiply it out. X squared times 6x squared will be 6x to the power of 4 plus 5 times 6x squared is 30x squared. Alright. Now 2x cubed times 2x will be plus 4x to the power of 4, and minus 7 times 2x is minus 14x. One more step, is that right? 6x to the power of 4 plus 4x to the power of 4 gives you 10x to the power of 4 plus 30x squared minus 14x is our final result. A very simple way to find the derivatives of products of functions. Alright, I would like you to try this now on your own. F of x equal to 3x plus 2x squared, that's the first function, times x squared minus 5x. Now stop the video and try this on your own, and then come back and see how I work it out. Alright? Okay, So the derivative here will be f prime of x equal to the first function, which is 3x plus 2x squared. First function times the derivative of the second function. So let's write that way. d by dx of x squared minus 5x plus the second function, which is x squared minus 5x times the derivative of the first function, d by dx of 3x plus 2x squared. Okay, let's now go to the next step. That will be, there will be no change here. We will find the derivative of the second function. That will be 3x plus 2x squared times the derivative of x squared minus 5x. Find the derivative of each term. What is the derivative of x squared with respect to x? It will be 2x, is that right? So that will be 2x. And what is the derivative of minus 5x with respect to x? It will be minus 5. So that will be 2x minus 5 is the derivative of x squared minus 5x plus x squared minus 5x times the derivative of 3x plus 2x squared. Alright, tell me what the derivative of these quantities are. The derivative of 3x with respect to x is 3 plus the derivative of 2x squared with respect to x will be 4x. Alright, let's now multiply this out. Very often students make mistake when you do these simple algebraic processes. Alright, let's multiply it out. 3x multiplied by 2x will be 6x squared, and 3x multiplied by negative 5 will be negative 15x, and 2x multiplied by 2x squared multiplied by 2x will be 4x cubed, and finally 2x squared multiplied by negative 5 will be minus 10x squared. And now let's come to the last term. X squared multiplied by 3 will be plus 3x squared. X squared multiplied by 4x will be plus 4x cubed. And then minus 5x multiplied by 3 will be minus 15x. And finally, minus 5x multiplied by 4x will be minus 20x squared. Alright, when you simplify and write your final expression, you must start with the highest power of x. So we have 4x cubed plus 4x cubed will give you 8x cubed. That is our first term. And now we come to the x squared term. Collect all the x squared term. 6x squared minus 10x squared gives you negative 4x squared plus 3x squared is negative 1x squared minus 20x squared will be minus 21x squared. I hope you understood that. 6x squared minus 10x squared is negative 4x squared plus 3x squared is negative x squared minus 20x squared is negative 21x squared. What are we left with now? minus 15x minus 15x is minus 30x. And so there you have our final expression, the derivative of the product of these two functions. All right? Okay. Now that you know how to find the derivative of product of two functions, let's discuss the quotient rule. How do you find the derivative of a quotient? Of the form, you have f of x equal to h of x divided by g of x. That's a quotient of two functions. How do you find the derivative of such a function? Now, according to the rule, I'm going to give you the rule right away. It's easy to use that rule. F prime of x equal to. Now watch this rule carefully and learn the various steps. You start with the denominator. So it will be the denominator multiplied by the derivative of the numerator, h prime of x, then minus the numerator, h of x, times the derivative of the denominator, that is g prime of x. Now, all over that quantity divided by the square of the denominator, that is g of x raised to the power of 2. That is the quotient rule. So, come again and talk about it one more time. What is the quotient rule? The quotient rule is if f of x equal to h of x divided by g of x, what is the derivative of f of x? F prime x equal to the denominator multiplied by the derivative of the numerator, h prime x, minus the numerator multiplied by the derivative of the denominator, all over the square of the denominator. That's a simple rule. Now try that a couple of times, write it down, and make sure that you understand the order. Don't mess up the order. Let's now use the quotient rule to find the derivative of f of x equal to x over x plus 1. Well, the denominator, the numerator. All right, let's talk over the rule one more time. What is the derivative of a quotient like this? It is denominator multiplied by the derivative of the numerator minus numerator multiplied by the derivative of the denominator all over the square of the denominator. Let's write that down. So that will be f prime of x equal to the denominator, that is x plus 1, times the derivative of the numerator, d by dx of x, minus the numerator, that is x, times the derivative of the denominator, all over the square of the denominator. Right? Okay, let's simplify that. That will be x plus 1 times the derivative of x with respect to x is 1. So that will be multiplied by 1 minus x times the derivative of x plus 1. What is the derivative of x plus 1? The derivative of x plus 1 is the derivative of x with respect to x, which is 1, plus the derivative of 1, that is 0. So the derivative of x plus 1 with respect to x is simply 1. All over square of x plus 1. There you go. Simplify that again, and that will be x plus 1. Let me write that properly. And that will be, I can probably write it over there. X plus 1 minus x all over x plus 1 raised to the power of 2. And what does that give you? Let me come over here. And that will be x plus 1 minus x. X and minus x will go. The numerator we simply have a 1. And the denominator is x plus 1 to the power of 2. So the derivative of f of x equal to x over x plus 1 is f prime of x equal to 1 over x plus 1 raised to the power of 2. Alright? Okay, let's try another simple function of the form f of x equal to 5 over x. Well, if you can find the derivative of this, that form will be true for any constant that you have on the numerator. Well, I will talk about that at the end of this. F of x equal to 5 over x. What is the derivative equal to? F prime of x equal to? What's the rule? Denominator times the derivative of the numerator. I'm not going to write that detailed step now. Let's practice this without that detailed step. Denominator, that is x, multiplied by derivative of the numerator. What is the derivative of 5 with respect to x? That is 0. So x multiplied by 0 minus numerator multiplied by the derivative of the denominator. Numerator multiplied by the derivative of the denominator. What is the derivative of x with respect to x? That is 1 all over the square of the denominator, x squared. One more time. I know some of you are slow, but practice this. You see, the more you write down, the better you learn these simple rules. So, denominator multiplied by derivative of the numerator. Derivative of a constant is 0. So, x multiplied by 0 minus numerator multiplied by derivative of the denominator. Derivative of x with respect to x is 1. All over the square of the denominator. What does that give you? X times 0 is 0. So that will be 0 minus 5 divided by x squared. And that will be negative 5 over x squared. Is that right? That's right. So, f of x equal to 5 over x. F prime of x equal to negative 5 over x squared. Okay, let me ask you this. If f of x equal to, say, 12 over x, what is f prime of x equal to? Use the same concept. If f of x equal to 5 over x, f prime of x equal to negative 5 over x squared. Similarly, if f of x equal to 12 over x, f prime of x will be negative 12 over x squared. Alright, let's practice a couple more of these examples. Well, I have f of t equal to 6 over t. What is f prime of t equal to? Well, it will be negative 6 over t squared. Well, if f of p equal to t 10 over p. What is f prime of p equal to? That will be negative 10 over p squared. Now, these are useful things. Now, generally, if I have f of x equal to, say, a over x, where a can be any constant, then f prime of x will be negative a over x squared. That's something that you can actually use anywhere when derivatives of such functions are desired. Okay. Well, let's look at this function, f of x equal to sine x divided by cos x. Alright, let's start by writing the form of its derivative. F prime of x will be, alright, what's the quotient rule? Denominator times derivative of the numerator. Let me write that in detail. Denominator is cos x times d by dx of sine x minus numerator times, numerator is sine x, times the derivative of the denominator, and all over the square of the denominator. Cos x times cos x is cos squared x. Alright, so look at that one more time. Denominator times the derivative of the numerator, d by dx of sine x, minus numerator times the derivative of the denominator, d by dx of cos x, all over the square of the denominator. Okay, that will be cos x times, what is the derivative of sine x with respect to cos x? I'm sorry, the derivative of sine x with respect to x. The derivative of sine x with respect to x is cosine of x. So that will be cos x times cos x minus sine x multiplied by, what is the derivative of cosine of x with respect to x? Derivative of cosine of x with respect to x is negative sine x. So that will be times negative sine x all over cos squared x. Alright, help me simplify this. That will be cos x times cos x is cos squared x, and look at this, minus sine x times negative sine x. The two negatives become positive, so that will be plus sine squared x all over cos squared x. Okay, now you help me simplify this. What is the value of the numerator? Sine squared x plus cos squared x, or cos squared x plus sine squared x. That is one of the first identities that you do in trigonometry. Is that right? Cos squared x plus sine squared x is 1. So the value of the numerator is 1, and the denominator is cos squared x. Alright, one more question. How do you simplify? Well, what is 1 over cos squared x? Well, you know 1 over cos x is secant x. Therefore, 1 over cos squared x is secant squared x. There you go. So the derivative of this function f of x equal to sine x over cos x is secant squared x. You can also learn one more thing from here, and that is, tell me, what is the simplified form of sine x over cos x? Another identity. Sin x over cos x is actually tan x. So, if I write now this equal to tan x, and if I ask you, what is the derivative of tan x with respect to x? It is secant squared x. Well, that's something that we will be using as we go on. The derivative of tan x with respect to x is secant squared x. And we worked it out using the quotient rule. Okay. Let's now find the derivative of f of x equal to 5x squared minus 3 all over 2x plus 5. Well, let's use the quotient rule. How do we write the quotient rule? Let's say f prime of x equal to denominator times the derivative of the numerator. Denominator, that is 2x plus 5, multiplied by derivative of the numerator. Can you tell me what the derivative of the numerator is? Find the derivative of each term. What is the derivative of 5x squared? The derivative of 5x squared is 10x. And the derivative of minus 3 is 0. So the derivative of 5x squared minus 3 is 10x. So we have denominator multiplied by the derivative of the numerator minus the numerator 5x squared minus 3 multiplied by derivative of the denominator. What is the derivative of 2x plus 5? The derivative of 2x with respect to x is 2, and the derivative of 5 is 0. So the derivative of 2x plus 5 with respect to x is 2. All over the square of the denominator is 2x plus 5 all squared. Alright, let's multiply and simplify. 10x multiplied by 2x is 20x squared, plus 5 times 10x is plus 50x. Now what's this minus sign? Everything you do here needs to be multiplied with that. 5x squared times 2 is 10x squared. With the negative sign gives you negative 10x squared. Minus 3 times 2 is minus 6. With this negative sign gives you 6, positive 6. All over 2x plus 5 all squared. And that will be, simplify the numerator, 20x squared minus 10x squared is 10x squared plus 50x plus 6 all over 2x plus 5 raised to the power of 2. And that is the derivative of that quotient function. Alright, suppose I ask you, find the derivative of this function at x equal to negative 1. Now, this notation means when. Now, find f prime of x when x equal to negative 1. Well, I'm going to write that over here. So, f prime of x when x equal to negative 1, all we need to do is replace your x by negative 1. And that will be 10 times negative 1 squared plus 50 times negative 1 plus 6 all over 2 times negative 1 plus 5 raised to the power of 2. Alright, can you simplify that for me? What will this simplify to? Well, negative 1 raised to the power of 2 is positive 1. So that will be positive 10. Now, 50 times negative 1 is minus 50. So this positive 10 minus 50 will be negative 40. Plus 6 will be negative 34. Is that right? Yes. So this will be 10 plus 6 is 16. Minus 50 is negative 34. We'll write that over here. Negative 34 on the numerator divided by, what is the denominator? This is negative 2 plus 5 is 3. 3 squared is 9. That is negative 34 over 9. Now what is the physical meaning of this? The derivative of f of x at x equal to negative 1 is negative 39 over 4. Well, remember the definition of derivative. Derivative of a function at a given point is the slope of the tangent line at that particular point. That means if you draw the graph of this function and draw a tangent line to the graph of that function at x equal to negative 1, the slope of that tangent line will be negative 39 over 4. That is the physical meaning of that. Alright, let's practice one problem like this as we go on. Let's try this problem. Find an equation of the tangent line to the graph of f of x equal to x squared plus 1 divided by x minus 1 at x equal to 2. We need to find the equation of the tangent line at x equal to 2. Tell me, what are the information you need to find the equation of a tangent line? The information we need are, alright, we need the slope of the tangent line. Well, the slope of the tangent line at x equal to 2 is the derivative of this function at x equal to 2. So, we obtain the derivative of this at x equal to 2, and that will give you the slope. What else do we need to find the equation of a line? Well, we also need a point. Well, we have a point. What is that point? When x equal to 2, what is the value of y? Well, f of x stands for y. So, replace x by 2 here to find the value of y. Can you give me quickly, what is the value of y when x equal to 2 from here? 2 squared is 4, 4 plus 1 is 5, 5 divided by 2 minus 1, 2 minus 1 is 1. So, when x equal to 2, the value of this quantity is 5. That means the point of tangency is x equal to 2, y equal to 5. So, once again, what are we going to do? We find the slope of the graph of this function at x equal to 2, which is the derivative of this function at x equal to 2. Alright, tell me, what is the derivative of this function? Well, we first of all find the derivative of f of x at x equal to 2. And that is, you know how to find the derivative. The derivative of a quotient is denominator x minus 1 multiplied by the derivative of the numerator d by dx of x squared plus 1 minus the numerator x squared plus 1 multiplied by the derivative of the denominator d by dx of x minus 1 all over the square of the denominator. Alright, help me do this. That will be x minus 1 times the derivative of x squared plus 1. The derivative of x squared is 2x and the derivative of 1 is 0. So the derivative of x squared plus 1 with respect to x is 2x minus x squared plus 1 times the derivative of x minus 1. What is the derivative of x minus 1? The derivative of x is 1 and the derivative of 1 is 0. So the derivative of x minus 1 with respect to x is 1. X squared plus 1 times 1 all over the square of the denominator. Alright, simplify that, and that will be 2x multiplied by x is 2x squared, minus 1 times 2x is minus 2x, minus, distribute that negative sign, minus x squared minus 1, all over x minus 1 all squared, and it simplifies to x squared minus 2x minus 1 over x minus 1 all squared. This is the derivative of the function. Now, we need the derivative of this function at x equal to 2. So, here we will replace x equal to 2 and find the value of this. Or, we will find f prime of 2. What is f prime of 2? To find f prime of 2, replace here x equal to 2. That gives you f prime of 2 equal to 2 squared minus 2 times 2 minus 1 all over 1. And that will be, well, you can simplify that. That will be negative 1. The slope of the tangent line at x equal to 2 of the graph of this function is negative 1. And what are we now supposed to find? We need to find the equation of the tangent line. The tangent line has a slope of negative 1 and it passes through what point? X equal to 2, y equal to 5. Well, let's find the equation of that tangent line. So to write the equation of the tangent line, we need its slope and a point on it. And when x equal to 2, f of 2 equal to 5. So our point is x equal to 2, y equal to 5. Tell me, how many of you remember what is the form of the equation called the point slope form? You have a point on the line and you have the slope of the line. How do you write its equation? Well, y minus y1 equal to m times x minus x1. Is that right? Yes. So we have slope equal to m equal to negative 1 and the point xy is 2, 6. It means, well, 2, 5, not 2, 6. It must be 2, 5. Alright, make that correction. Our x1 equal to 2, y1 equal to 5. And so our equation will be y minus y1 equal to m times x minus x1. Our x1 is 2, y1 is 5, not 6. Alright, our m equal to negative 1. And so we have y minus y1, y minus 5 equal to m is negative 1. Is that right? We've got m equal to negative 1 times x minus x1, x minus 2. And simplify that. Simply distribute this. That will be negative x plus 2. And bring the 5 to the other side. You get y equal to negative x plus 7. And that is the equation of the tangent line at x equal to 2. That has a slope of negative 1. And passing through x equal to 2, y equal to 5. Now, can you draw a graph of that? Well, actually it looks like this. Okay, let me show you how that can be done on your calculator. I'm going to show you how a tangent line can be drawn at x equal to 2 for this function graph. Well, this is your TI-84. To draw a tangent line at a particular x value, go like this. Now watch the keystrokes. Now if you look at the menu, look at where the mouse is, look at the draw menu. It is the second program gives you the draw menu, and what we need to do is number 5, tangent. So plus 5, we need tangent of the function. What is our function? Our function is x squared plus 2, is that right? Well, our function is x squared plus 1, so you need to enter that in parentheses. So that will be parentheses, x, the x variable, square it, x squared plus 1, close parenthesis, divided by, parenthesis, the denominator is x minus 1. Alright, so you got the function down there. Now put a comma, and then we want this at x equal to 2. So simply after the comma, have a 2. And end the parenthesis, and then enter. Well, you also need to adjust the window. Now, you need to adjust the window so that you get the graph on the window. Now, watch the window I have set. X minimum -5, X maximum 5, X scale 1, X minimum -2, Y minimum -2, Y maximum 10. And that window is, I think, good enough. Alright, let's quit this and enter. You can see the graph is drawn there. Alright, that is the tangent line drawn at x equal to 2. And it is this tangent line that we found the equation of some time ago. Okay. Okay, let's try this problem. Determine the points at which f of x equal to x squared over x squared plus 1 has a horizontal tangent line. What is the characteristic of a horizontal line? Well, in terms of its slope. What is the slope of a horizontal line? Well, the slope of a horizontal line is 0. In other words, what does this question mean? Determine the points at which. Points, point or points. If you take it singular, let's say, find the point where the derivative of this function is 0. How do you find the point where the derivative is 0? Find the derivative of the function, set it equal to 0, and solve for x. That will give you the x value where the derivative is 0. Is that right? Okay, let's do that. So horizontal tangent line occurs at points where f prime x equal to 0. So all we need to do is find the derivative, set it equal to 0, and solve for x. What is the derivative of a function like this? It will be denominator multiplied by derivative of the numerator minus the numerator multiplied by derivative of the denominator all over square of the denominator. Alright, let's now simplify that. That will be x squared plus 1 times, what is the derivative of x squared? The derivative of x squared is 2x minus x squared times the derivative of x squared plus 1. The derivative of x squared with respect to x is 2x, and the derivative of 1 is 0. Therefore, the derivative of x squared plus 1 is 2x. So x squared times 2x all over x plus 1 all squared. But you don't really need to simplify this. What all you need to do is set this equal to 0. But in order to set this equal to 0, you need to simplify that. So let's do that. And that will be, distribute that 2x. 2x times x squared is 2x cubed. 2x times 1 is 2x. And that will be that term multiplied. Minus x squared times 2x is minus 2x cubed. All over x plus 1 all squared. On the numerator, 2x cubed minus 2x cubed goes, and that will be 2x divided by x plus 1 all squared. Alright, can you tell me, looking at this, what is the x value at which this slope or this derivative is 0? What x value will make this quantity 0? Remember, when a quantity like this, a rational, when you have an expression with a numerator and a denominator, that becomes 0 when the numerator is 0. Is that right? Because the denominator cannot be 0. 0 divided by anything is 0. Therefore, this becomes 0 when 2x equal to 0. Or this becomes 0 when x equal to 0. That's right. So for a horizontal tangent line, f prime of x equal to 0. It means 2x divided by x plus 1 all squared equal to 0. And this can happen only when 2x equal to 0 or x equal to 0. Therefore, tell me, what is the point where you have a horizontal tangent for this function? Well, if x equal to 0, what is the value of y? What is our function? Our function is, if you remember, let me write down that function for you. Well, our function is f of x equal to x squared over x squared plus 1. And we know that a horizontal tangent line exists for this function at x equal to 0. Now, what is the value of f of 0? In other words, what is the value of y when x equal to 0? When x equal to 0, this whole thing will be 0. That means when x equal to 0, y also equal to 0. Or f of 0 equal to 0. So what is the point of horizontal tangency? The point of horizontal tangency will be 0, 0. That means this function will have, this function graph will have a horizontal tangent at the point 0, 0. That's the meaning of that. Alright, can you draw the graph of this function and draw a tangent line at 0, 0, just like I showed you? Try that on your calculator now. Well, I hope you got this graph. This is the graph of the function, and the tangent line drawn at x equal to 0 is that horizontal line. Okay, let's try another one. The velocity of a car starting from rest is v of t equal to 100t divided by 2t plus 15. Find its acceleration, 1 at t equal to 10 seconds and 2 at t equal to 25 seconds. Well, you are given the velocity function. You need to find the acceleration. How do you get the acceleration from velocity? Remember, acceleration is the rate of change of velocity. In other words, acceleration is the derivative of the velocity function. So the question simply is, what is the derivative of this function at t equal to 10 seconds and at t equal to 2.5 seconds? That's all we need to do. So we got a of t equal to v prime of t. The acceleration is the derivative of the velocity function. And this is the velocity function. So let's find the derivative of that. How do you find the derivative? Remember, the quotient rule, the denominator, that is 2t plus 15, times the derivative of the numerator, the derivative of 100t with respect to t. The independent variable here is t, minus the numerator 100t times the derivative of the denominator 2t plus 15 all over the square of the denominator. Okay, help me simplify this. Well, if you go here, the derivative of 100t with respect to t is 100, is that right? So that will be 2t plus 15 times 100 minus, what is the derivative of 2t plus 15? The derivative of 2t with respect to t is 2, and the derivative of 15 is 0, so the derivative of 2t plus 15 is simply 2. So that will be 100t times 2. Let's write that down. That will be 2t plus 15 times 100, derivative of 100t with respect to t, minus 100t multiplied by 2, the derivative of this, all over 2t plus 15 all squared. Simplify that, that will be 200t plus 1500 minus 200t, simply simplify the numerator. And 200t will cancel, that will give you 1500 divided by 2t plus 15 all squared. Now this is the acceleration function. Acceleration as a function of t. We want to find the acceleration at t equal to 10 seconds. In other words, we want to find the value of a of 10. A of 10, replace your t by 10. There you are. And simplify this, what do you get? You can do that on your own. That would be 1.22 meter per second squared. Similarly, what is the acceleration at t equal to 25 seconds? Not 2.5, 25 seconds. So a of 25 is, similarly, replace your t by 25. And the denominator now is, look at this, 2 times 2.5 is 5. 5 plus 15 is 20. 20 squared is 400. 1500 divided by 400. Well, is that 0.36? Yes, as I have been reading this as 2.5. This is 25. So that will be 2 times 25 is 50. 50 times 15 is 65. So 1500 divided by 65 squared is 0.36 meter per second squared. All right. Okay. Another one. Find the second derivative of f of x equal to x over x plus 1 at x equal to negative 2. So you've got to find the first derivative and then its derivative. That is the second derivative. Is that right? Okay, let's try that. First of all, we find f prime x, or f of x equal to x over x plus 1. So f prime x equal to, all right, practice that quotient rule. It'll be denominator x plus 1 times the derivative of the numerator minus the numerator times the derivative of the denominator all over the square of the denominator. Well, you know these things now very well. The derivative of x with respect to x is 1. Also the derivative of x plus 1 with respect to x is 1. So this is 1 and this is 1. That will give you x plus 1 times 1 minus x times 1 over x plus 1 squared. When you simplify that, what do you get? Well, you know that this x and that will cancel. The numerator is simply 1. So that will be x plus 1 minus x over x plus 1 squared, and that is 1 over x plus 1 squared. That is the first derivative. We now need to find the second derivative. Is that right? Alright, can you do that on your own? Find the derivative of this using the quotient rule. Well, I hope you succeeded in doing that. This is our f prime x, 1 over x plus 1 all squared. F double prime x is the derivative of this quantity. And we use the quotient rule again. How? Denominator multiplied by derivative of the numerator minus the numerator times derivative of the denominator all over the square of the denominator. X plus 1 all squared become x plus 1 to the power of 4. Okay, let's try that. That will be x squared plus 1 times the derivative of 1 is 0. And in order to find the derivative of x plus 1 all squared, we haven't yet found a rule for such quantities. So we need to first of all expand it. Now x plus 1 all squared is x squared plus 2x plus 1. That's no problem for you. So this is derivative of x squared plus 2x plus 1 all over x plus 1 to the power of 4. Of course this is 0. Alright, can you tell me, look at this, tell me what is the derivative of this quantity? X squared plus 2x plus 1. Find the derivative of each. The derivative of x squared is 2x. The derivative of 2x is 2. The derivative of 1 is 0. So the x squared, the derivative of x squared plus 2x plus 1 will be, alright, 2x plus 2. That negative sign. So that will be 0. That will be 0 minus the derivative of x squared plus 2x plus 1 is 2x plus 2. And here you can factor out a negative 2. That will be negative 2 times x plus 1 over x plus 1 to the power of 4. You have an x plus 1 on the numerator, x plus 1 to the power of 4 on the denominator. You can cancel one of those, and the result will be therefore negative 2 divided by x plus 1 to the power of 3. Well, we need to find the value of this at x equal to negative 2. F double prime of negative 2. The second derivative at x equal to negative 2 is replace your x by negative 2. And what's the value of this? Negative 2 plus 1 is negative 1. Negative 1 to the power of 3 is negative 1. Negative 2 divided by negative 1 is positive 2. So the derivative of the given, the second derivative of the function at x equal to negative 2 is positive